Hi students, this is like take number 10, trying to get these videos to be shorter. And here's the deal, we're going to graph sine and cosine today, and I want you to write down these notes right here, so I won't be making a 20-minute video. It's important that you know these things about periodic functions and sine and cosine. And now the next, so freeze it and write that down. The next thing I want you to do is we're going to examine the anatomy, if you will, of a sine function. Let me show you. Okay, here is what I wrote a while ago, that the basic function is a times cosine of bx, or y equals a times sine of bx. But what happens is this, when I have y times that trig function, and trig could be cosine or sine, times b of x minus h plus or minus k. I want you to write this down. This is standard form, and I'm going to identify what each letter does. Okay, so on A, that is your amplitude, and that actually tells you the distance from the rest, from the at-rest distance from, Okay, so your amplitude is the distance from the at-rest or the midline. At-rest is your midline. And now you have your period for B, and the period is actually your cycle. In physics, they call it a wavelength. So you determine this by doing 2 pi over B. So write down that you determine the wavelength by doing 2 pi divided by B. Now, if you have a phase shift, it will be in a parentheses. It'll be stated as a binomial there. Sometimes they use x, sometimes they use theta, but the h is your phase shift. We won't be doing that today. And k is your vertical shift, but it is also your midline. Okay, so write those things down. Okay, this is kind of messy because I kept trying to redo this, make it faster. But here's the deal. If I have 5 equations really fast, I want to show you how to do the amplitude. The amplitude is right in front of the trig function. So here the amplitude is 3. Here it is 1/2. You can imagine this next one is 2. This next one is what? It's not 0, it is 1. And this is 5. It's not -5, it is 5. The fact that it's negative just means that instead of graphing like this, it'll graph like this. Okay, so that's it. And now your period on each of these will be 2 pi divided by whatever precedes that x or that theta. So like on this one, it is going to be 2 pi, let me see if I can write it in, 2 pi divided by 2, which is just pi. So the length of the period will be pi. Don't panic yet. You don't have to panic at all. If you'll follow these steps, it'll be easy, okay? On the next one, it's 2 pi over 3, right? Because the b is 3. The b was 2. Here the b is 1/2. So what is 2b? Let me write it up here. 2b divided by b when b is 1/2. Isn't that just 4 pi? I think so. And now what is 2b divided by b when the b is 4? Well, 2 over 4 is 1/2, and the pi's are going to cancel, so it's just going to be 1/2. And now in this next one, you have 2 pi over b when the b happens to be pi over 2. So what do? It's a complex fraction. 2 pi over 1 times the reciprocal, 2 over pi. Look what happens. The pi's are canceling, and it's just 4. So notice that your period can be just a simple value, or it could be a simple value with pi. Again, no need to worry. We will get there. Lesser mortals have done this. And now the midline's really easy to find. In this case, there's no k, so it's really assumed to be 0, so it's 0. So the at-rest line is 0. Oh, here it goes again. Okay, on the next one, it's 2. The midline is 2. On the third one, it's 1. I think I'm off kilter here now. This one is 3, and this one would be 0. So, sorry I've got this off kilter, but hopefully you get the point. So let me make one more point before we start graphing. If you'll notice a unit circle, I don't want to graph these points. I don't want to graph pi over 2. I don't mind if it's on my x, because I'd be writing that in. But on the y, trying to figure out what root 3 over 2 is, or negative root 3 over 2, I don't want to do that. I want to graph these points, which are my quadrantals. And those quadrantals are all zeros and ones, which is really super easy to graph. Even if I had to multiply it by 3 or 4 or 5, it's still easy. So that's our point. And even nicer, it makes sense because this is going to be a midline. This is going to be the highs, another midline, and the low. I will be getting what they say in science is the crests and troughs, which is the maximums and the minimums, which is perfect. So the first thing we're going to do is make our table. So let's take this one, y equals 2 times sine of 1/2 x. I'm going to start with a hard one instead of an easy one. Oh my. So the first thing I like to do is make my xy chart. I probably should have put that in the directions, but you'll see. All right, start at your phase shift or 0. And I know you're saying, what? Well, there is no phase shift here, right? There's no x minus 2 or x minus pi over 6. So my phase shift is non-existent, therefore my first x will be 0. Step 2, determine your period. Now remember the period is 2 pi divided by b. In this case, b is 1/2. So 2 pi divided by 1/2 would be what? 4 pi. So now 4 pi goes in this last thing. So in other words, I need 5 points. I need 1, 2, 3, 4, 5 points. I'm going to come full circle. And to do that, I'm numbering it from 0 to how big the cycle is, or the wavelength, or the period. And now, if I want to get those quadrantals, I need to bisect this. I need to find the midpoint and then the midpoint again. So look at the 0 and the 4 pi. What's halfway in between 0 and 4 pi? 2 pi. So I put in the middle. Now find the midpoint of these two. What's halfway between 0 and 2 pi? 1 pi. And now for this side, halfway in between 2 pi and 4 pi is 3 pi. We are doing well. So you have it divided up perfectly, so it's going to be easy. And now you just have to plug it in. Now think. Okay, sorry, I had to simplify my drawing. So now let's think. If I have 2 times sine of 1/2, and I'm going to put this 0 in right here. Go from the inside out. What's 1/2 of 0? It's 0. What is the sine at 0? So the sine at 0 right here is 0. And 0 times 2, because I have that 2 sticking there, is still 0. So now let's do the next one, which is what's 1/2 of pi? So I'm using this pi right here, sticking it in. What's 1/2 pi? Well, it's pi over 2, which is right up here, correct? And pi over 2 has a sine of 1. Now, I've already done the 1/2 pi. I don't multiply it by that by 1/2. I've already done 1/2 pi, gotten right there, and that value for sine is 1. Now take that 1 times that existing 2, that's a coefficient in the front, because that's what it is, and you get 2. All right, now let's do 2 pi. If I put 2 pi right here, sorry, I shouldn't just scratch over it, looks terrible. Okay, if I put 2 pi in right here, what's 1/2 of 2 pi? It's pi, which is here on my graph. So the sine at this pi is 0, and 0 times 2 is 0. And now let's do the next one. If I put 3 pi, what's 1/2 of 3 pi? You bet it's 3/2 pi, which is, you guessed it, right there. What is the sine right there? The sine at 3/2 pi is -1. You multiply it by the coefficient of 2, and you get -2. And finally, you've come full circle. We're going back here. So what is the 1/2 of 4 pi? Because now I'm putting 4 pi in right here. 1/2 of 4 pi is 2 pi, which brought me here. And the sine there is 0, and 0 times 2 is 0. Now I have my points. And what I like about this is I know exactly how big to make my graph. On my graph, let me erase something. On my graph, I let my table guide my graph. Like this is going to be 0, this is going to be pi, this is going to be 2 pi, this is going to be 3 pi, This is going to be 4 pi. Whatever I labeled my x, that's what I labeled this x, because it makes it simple. And now, look, I only have to go from 0 to 2. So I have 0, 1, and 2. When x is 0, y is 0. When x is pi, the y is 2. When x is 2 pi, right here, the y is 0. When x is 3 pi, it's negative 2. Forgot to put those 2 points on. So I'm going to go down here. And then when x is 4 pi, it's 0. And now I have my function. Now you can imagine that it continues. It's periodic. So you can actually just count your grid and continue to graph this and take it past one cycle or one wavelength. And that's how you do these. Now we are already at 10 minutes, almost 11. So I'm going to stop. Tomorrow you come with these directions. And let me show you one more screen. This is things I want to say, but we don't have time. So read that. Take care. Bye.